Welcome to Engage Math, Lesson 13, Problem 2. And I took the liberty of already setting up what your variables could be equal to. You might come up with X and Y, but I based it on the question, how much does she charge for each item? So in this situation, we're going to solve all the systems by elimination, since that is the theme of Lesson 13, solving systems of equations by elimination. So the first thing we know is that on Saturday, Mia sold 93 cookies and 41 brownies. So what we know is that 93 times whatever the price is for a cookie plus 41 plus whatever the price is for a brownie, so 41 times the price of the brownies equals the total amount that she earned that day of $151.75. Okay, the other thing we know that on Sunday she had a similar situation, but she only sold 31 cookies, and here she sold 5 brownies, and in this case, she made a total of $33.25. So our goal is to use these two equations to solve for both C and B, the price of cookies and the price of brownies. If you look at the two equations, it might not appear that obvious to you, but there's a big kind of hint here. If you look at these two C's, the second one, 31C, can be multiplied by a -3 to give us a -93, which will allow us to eliminate one of the variables. So that first variable, I'm just going to rewrite. 93, the first equation, I should say, 93C plus 41B equals 151.75 or $151.75. The second equation, I'm going to multiply through by -3. So I'm putting a -3 there, so you see that I'm going to get a -93C. Remember that -3 has to distribute to everything. So minus 15B equals, and -3 times the $33.25 is going to be a -$99.75. Now we can add these together. Now remember, you get a calculator for this problem. So when we add the 41 minus the 15, we get 26B, and then the difference between 151 and 99 is going to be 52. So we now have 26B equals 52. Divide both sides by 26, and we get that B is equal to 2, which means the price of brownies, which I'm going to change that color right here, the price of brownies is $2. So $2 per brownie. Okay, that's supposed to be an arrow. It's not very neat though. Okay, so now based on the price of brownies being $2, we can take either one of the equations and solve for the price of cookies. So I'm going to just use that bottom equation, and what we have is 31C. So I'm going to just write down right here in green so you can see it, 31C plus, I'm putting 2 in for B, so plus 10 is equal to 33.25. Okay, I'm going to subtract 10 from both sides, so I'm going to get 31C equals 23.25. And when you divide both sides by 31, you're going to get the price of cookies, and that's going to be 75 cents, because you're going to do 23.25 divided by 31, and that should give you 75 cents for the price of each cookie, which I'm going to write over here. So it's, let me rewrite that. So it's going to be 75 cents. So I'm just going to write it like this. That's the price of a cookie. All right, the next two problems are both light bulb problems, so hang in there for these. All right, so we have $2,900 to invest, and we already have the variables set up. So what I'm going to start with is the total amount of money invested is X plus Y, and that's equal to 2,900. Okay, now what we know is that the amount he put in at 6% is X. So 6% is the same as 6 out of 100, or 0.06x, 0.06, so it's 0.06x plus 0.05y is equal to the total amount of interest. But there's one thing that's missing. We need 2 years if we look at our simple interest problem. So we can either multiply each one of these by 2 and say like 0.12x because it's the interest rate times the principal times the time. But I'm going to do something a little bit different. I'm going to just leave the amount of time as 1. And if we earn $324 in 2 years, I know we earned half of that each year, which is $162. So that just makes our numbers a little bit easier. And now I'm going to multiply the entire second equation through by 100 to get rid of those decimals. So I'm going to rewrite x plus y equals 2,900, just to make sure you see how I got 162. I took half of 324 because I am saying if in 2 years we earned this amount, in 1 year we earned $162. So x plus y equals 2,900, and then I'm going to make this 6x plus 5y equals, and I have to add 2 zeros onto that 162, so 16,200. All right, so now I'm going to multiply this top equation through by either a -5 or a -6. I'm going to choose the -5. So it's going to be -5x minus 5y. And you get your calculator for this. But you can also think of 5 times 2,900. You could do 5 times 3,000. But if you do 5 times 2,900, it's like 5 times 3,000, but 500 less than that. So what you're really going to get there is 14,500, but it's negative. So we're going to get a negative 14,500. And then we have 6x plus 5y equals 16,200. We add these together, the y's cancel, and we right away get that x is equal to the difference between negative 45,000 or negative 14,500 plus 16,200. And remember, x represents the amount at 6%. So that amount is going to be, the difference between those two numbers is going to be 1,700. So the amount we invested at 6%, I'm just going to write that up here, equals $1,700. And so we know since we invested $2,900 altogether, y, we don't even have to do any work, must be 1,200. So we know how much we invested at each amount. All right, let's go to the distance, rate, time problem. I just want to remind you that distance that's traveled is equal to your rate times your time. So x is equal to the jet speed in still air. So what we're going to do is we're going to put that in, because in still air, if we can fly the jet at x, in this case, it's going to be miles per hour. What we know is that on the way from London to Rome, it's 2 hours with a tailwind. So your speed is not going to just be x, it's going to be x plus the tailwind. Whereas on the way back, you have a headwind of y, so it's going to be x minus y is your rate on the way home. Okay, so now on the way there, it took 2 hours. So everything's in miles and hours. So I'm going to say our time was 2 on the way there. And on the way back, it was 2 hours, 15 minutes. Being a light bulb problem, I'm just going to jump right ahead to making this 2 and 25 100ths, because 15 minutes is 1/4 of an hour. Now, the distance then in both cases was 900 miles. So what we know is we could set up two equations. I'm going to kind of say that rate times the time is equal to the distance, which is 900 in both cases. So I'm going to write our first equation as 2 times x plus y, rate times time equals distance. And then on the way back, it's going to be 2 1/4, so 2.25 times x minus y equals 900. Okay, now as we do this, I'm going to just distribute that. So I'm going to kind of keep going with this. 2x plus 2y equals 900. And then 2 1/4 or 2.25 or 2 and 25 100ths x minus 2 and 25 100ths y is also equal to 900. So the way that we can get this variable to cancel is either the x or the y. I think I'm going to go with the y since it's already a positive and a negative. So why don't we do that? And since we have 2 1/4 and then we have a 2, this is a light bulb problem, so I'm going to kind of jump to this a little bit. But if we multiply the top equation through by 5 and the bottom equation through by 4, Let's see if that would work, because we would get 10 up here. Oh, but down here we'd only get 9. So maybe the best way to think of is you're really multiplying by the opposite coefficients again. So all we have to do is we're going to multiply the top equation through by the coefficient on the y. So I'm going to put a times 2.25, and the bottom equation is going to get multiplied through by 2. So that will give us, on the top, we're going to get 4.5y, and on the bottom, we're going to get a negative 4.5y. So I know that a lot of times people think you can just do like a 4, and kind of get something that way. Not in this case. So you're going to have 4.5x. So I'm going to write that right here, 4.5x plus 4.5y equals. And then you have 900 times 2.25. And 900, the one way to think about that is it's times 2, which is 1800, and then another quarter of that, which is another 225. So you're going to get a total of 2025 right here. Okay, and then in the second equation, you're going to get 4.5x. And here you're going to get minus 4.5y, which is exactly why we picked the opposite coefficients, equals 1800. Okay, let's now add these together. I'm going to make that blue line, which is really already there, and we're going to get 9x equals, and then everything's being added, so we're going to get 3825. And so you're going to divide 3825 by 9, and you should get a value for x of 425, which means that the speed of the jet in still air is 425 miles per hour. And then to get the value of y, we can take any of these equations and solve for the y variable. So I'm going to do that right here for you in a different color. I'm going to use this equation, the 2x plus 2y equals 900. So we know x is 425. So 2 times 425 plus 2y equals 900. So that's going to give us 850. So we have 2y equals 900 minus 850 gives us 50, and y equals 25. So the speed of the wind is 25 miles per hour. And that is all we need to know. So we're done.